Okay, so now let us take a look at the adjacent angles. Now, two angles are said to be adjacent if they share a common vertex and a common side, but they do not overlap. Let me explain this. Now, when we say two angles are adjacent, in a layman's term, it means that these two angles are next to each other. So, an example, if I have this over here, and this is angle A, this is angle B, this is angle C. Now, from this diagram over here, you can see that the angle A and the angle B are next to each other. So the angle A and B are adjacent angles. They share a common side. This is the common side. They share a common side and they share a common vectors. This is the common vectors. Okay. So the angle A and the angle B are adjacent. They are next to each other. Same way, we can take the angle B and the angle C. The angle B and the angle C are also adjacent. So the angle B is next to the angle C. So these are adjacent angles. Now the angle A and the angle C are not adjacent. So the A and the C, these two angles over here, they are not adjacent. They are not adjacent in the sense that you can see that they are not next to each other. For you to move from A to C, you have to pass through B. Okay, so they are not adjacent. So for them to be adjacent, they would have to share a common side and a common vectors. So they are not next to each other. So therefore, the angle A and the angle C are not adjacent angles. But the A and B are adjacent, the B and C are adjacent. So that is it for the adjacent angles. So as you can see from this diagram, the A, as you can see from the diagram over there, the A and the B over here, they are adjacent angles. So they are next to each other. Now we can talk of the linear pair. So a linear pair is a pair of adjacent angles whose non-common sides form a straight line. So they are always supplementary. So in the layman's term, what basically a linear pair is an adjacent supplementary angle. So when two angles are next to each other, so when I have two angles, let's say angle A and angle B, and let me say this line over here is a straight line, and these two angles over here are next to each other. So the A and B are adjacent. So that is the first condition. They must be adjacent and they must add up to 180. So when I add, I get 180. So when this happens, then we say that the angle A and the angle B are linear pairs. So again, for there to be a linear pair, the two angles will have to be adjacent and they will have to be supplementary. That is, they have to add up to 180 degrees. So when two angles are adjacent, and supplementary, then it means that they are linear pair. Then the vertically opposite angles. So two angles are said to be vertically opposite when two lines intersect the angles opposite each other. So take note of this. The angles opposite each other are vertically opposite angles and they are always equal. So in this case, I have the line AB and I have the line CD. Now you can see that this angle is opposite to this angle. So therefore these two angles over here, the ones in the orange color, they are vertically opposite angles. And this angle over here, the one in the green, and this angle over here are also vertically opposite. So therefore they are also the same. So vertically opposite angles are formed from the intersection of two lines. So if I have a diagram like this, and I have this angle as A, this is B, this is C, this is D, this is E, and this is F. If I have this over here, then I can say that the angle B and the angle E are vertically opposite. So B and E are vertically opposite. You can see that I have this line over here and I have this line over here. The angles on the opposite side over there is B and E. So therefore B and E are vertically opposite angles. And I can also say that the C and the F are also vertically opposite. So the C and the F are also vertically opposite. So if I take this line and I take this line, you can see that with just these two lines, this angle is opposite to this angle. All right. So it means that the C and then the F are vertically opposite. The same way the A and the D. So the A and the D are also vertically opposite. So the A and the D are vertically opposite. Same way, if I take this line over here and I take this line, you can see that the A is opposite to the D. So the A and the D are vertically opposite. And take note, all vertical opposite angles are equal. So therefore, the B is equal to the E, the C is equal to the F, and the A is equal to the D.